Hello, welcome back to Introduction to Statistics. In the previous session, we learned that descriptive statistics involves organizing and summarizing data by grouping data into exclusive categories. And predictive statistics involves predicting the property of a population based on its sample. We can perform data analytics based on the type of data we have and its classification. In this session, we shall cover classification of data. So, how is data classified? Data is classified into 4 levels of measurement: nominal, ordinal, interval, and ratio. The type of data within these 4 levels of measurement determines what type of calculations can be performed on the data. Qualitative data are represented within nominal and ordinal scales. Quantitative data are represented within interval and ratio scales. As we remember from the previous session, qualitative data can be grouped into a frequency table. So data in the nominal and ordinal scale can be grouped. The difference between nominal and ordinal scale is that nominal data is unordered while ordinal data is ordered. Nominal data is unordered because it cannot be arranged in any particular order. It has no direction. Why? Because it is the type of data which nominal scale deals with. For example, you answer survey questions like what is your nationality, what is your gender, what is your hair color. Surveys could ask you questions that result in yes or no, such as do you like Hawaiian pizza by Domino's? Your answer shall be either yes or no. Yes or no is based on consumers' opinion. Similarly, political outlook is based on opinion. Opinions cannot be arranged in any order. Likewise, gender, nationality, colors are the kind of answers which cannot be arranged in any order. So that's nominal data for you. It has no order, no direction, but the survey results can be grouped into a frequency table. Ordinal scale is just like the nominal scale, except that its categories are ordered. Let's say you design a survey and use a Likert scale. Likert scale is when you group likability from strongly disagree to strongly agree, or from very dissatisfied to very satisfied. And then you ask questions like how satisfied are you with the taste of the Hawaiian pizza by Domino's? Are you satisfied with the toppings? And you could ask many more such questions. You could ask the same questions for Pizza Hut and other pizza companies. Then based on the answers, you can rate or order the companies in a rank. You can rank the data like say top 5 companies based on the consumer satisfaction of the Hawaiian pizza. In this case, you're classifying data on the ordinal scale. Ordinal data is ordered. You can rank, but you cannot measure the difference between data because we cannot quantify the difference. We cannot measure how much is the difference between agree, neutral, and disagree. So that's ordinal data. Now let's move on to ratios and intervals. We remember from the previous session that numeric data are quantities and they can be measured. So the interval scale and ratio scale which deal with quantitative data are measures. They are measures because they can be measured and they can give us the difference between measurements. But the interval scale has no true zero, it has no absolute zero. Let's say your data is about food and you had to arrange temperatures in a scale. So you mentioned the temperature to bake cakes is between 177 to 190 degrees centigrade. Here you are talking about intervals between two numbers, from 177 to 190. In the interval scale, a true zero cannot exist because the interval is a value between two numbers. There is no zero starting point. The values can be negative numbers. For example, 0 is not the lowest degree in the temperature scale. For freeze drying, you might need minus 50 to minus 80 degrees centigrade. So in the interval scale, no true zero can exist. For ratios, a true zero can exist because you're dealing with data which start with a zero, as in age, length, breadth, width, height. No negative values are possible for this type of data. You cannot have minus 11 in kilometers or minus 5 as an actual age. Going back to a survey example, let's say you design a survey which compares the amount of sales of different pizzas between Domino's and Pizza Hut. For sales, you need a scale of numbers. Then you can use ratios to measure the difference between the data. So as you can see, the type of data in the data set determines what type of statistical operations we can perform on them. Therefore, it is imperative to have different types of data in a data set. We can do this by designing surveys, questionnaires, forms which ask for different types of data. Then we can categorize data into measurement levels and perform suitable statistical operations on them. A good survey will have a combination of nominal, ordinal, interval, and ratio scales. Qualitative data is good for generating hypotheses. For example, they can generate insight into preferences and they can help us decide how the Hawaiian pizza can be marketed. But we must remember the customer is stating his preference, and preferences are hypothetical, they're subjective. What he actually buys demonstrates his true preference. There is always a difference between the customer's stated preference and the actual purchase. How can we describe this? Now let's say you have a business idea. The idea is to start a gym in a particular locality. Before you build a gym, you conduct a survey to check how many gym memberships you can sell. I think the gym is always a great example to show how stark the difference can be between the stated preference and the actual outcome. You see, if you ask anyone, would you like to go to the gym daily? Majority will tick yes. But can this translate to actual purchase? Will it result in sales of gym memberships? The reality is different because in reality many hardly go to the gym. So you will need to find ways how to measure the difference between the stated preference and probable memberships through a series of questions. The questions you design should pinpoint how much sales you can get to the best extent possible and whether your investment can fetch you the kind of returns you're expecting. There are best practices in designing questions, whether it is for generating pizza sales, for selling gym memberships, or for any general survey. Organizations ask you questions all the time, whether it is a KYC form or a questionnaire to decide whether a patient requires medical surveillance. You could use different questions such as rating scale questions, Likert scale questions, ranking questions, drop-down questions, open-ended questions, and so on. As a general thumb rule, a survey should be free from bias unless you want to measure bias and you want to use some marketing collateral or advertising to play on the consumer's bias to induce him into making a purchase. The survey must be highly accurate to enable proper categorization. It should not mention possible choices because then you may not get the accurate result. Instead, as a survey designer, you must provide very specific choices which enable you to have proper classes or categories or groups. So once we have data to the most accurate extent possible and have classified them, we can start performing operations based on the type of data. We perform operations on data so that we can get information from them. To get information, as a first step, we need to know how to compute central tendency measures and spread. Of all 4 levels of measurement, we get the least amount of information from nominal data because it is simple data in character format. This data also requires a lot of analysis. The ratio scale gives us the maximum amount of information because variables in the ratio scale can be added, subtracted, multiplied, divided, and since we can have mathematical operations on them, we can compute central tendency measures such as mode, median, and mean. Ratios can also be dispersed, so we can compute dispersion measures like standard deviation and coefficient of variation. These operations cannot be performed on qualitative data. Here in this table, we see phrases like measures of central tendency, measure of spread, and other terms. In this session, we will cover the 3 main measures of central tendency, which are mean, mode, and median. We shall also cover IQR, range, and outliers. Very simply put, mean is the average, median is the middle number, mode is the most frequently occurring number. We will go into detail into these concepts in later sessions, but for now let's just understand them in a simple way. Here we have a dataset with 5 items in it: 2, 3, 3, 8, and 20. To find the mean, we simply add the numbers and divide the total by the total number of items in the dataset. So when we add 2 plus 3 plus 3 plus 8 plus 20, we get 36, which we divide by 5 to get the mean 7.2. To find the median, we sort the numbers in an ascending order and then we strike off from both sides. Whichever number remains in the middle is the median. Median is the middle number in a sorted list. The list must always be sorted first. It is easy to find the median in a list with an odd number of items. Here in our list with odd number of items, we found the middle number or the median is 3. Let's say the list has an even number of items. To find the median, you just add both the numbers in the middle of the sorted list and find their average. For example, in our data set with an even number of items, we have 3 and 4 in the middle. So we find their average 3.5, which is the median for the given data set. Mode is the most frequently occurring number, and in our data set, the most frequently occurring number is 3. But if there is more than one frequently occurring number, then both the numbers are the modes. In our last row here, we see 3 and 4 both occurring an equal number of times, so we have a bimodal data set. Now let's check what is the range of our data set. Range is the difference between the maximum value and the minimum value. In our data set, the highest value is 20 and the lowest is 2. Their difference is 18, so 18 is the range of our data set. To find the interquartile range or IQR, we divide our data set into equal parts. The minimum is 0% and the maximum is 100%. From 0% to first quartile is 25%. From 0% to second quartile is 50%. From 0% to third quartile is 75%. And from 0% to fourth quartile is 100%. Here we have the data set 2, 8, 3, 3, 20, 4, 4. To find the IQR of our data set, we first find the median. We sort the numbers into an ascending order, strike off from both sides to find the middle number of our data set, which is 4. We then divide the data into two halves with 4 in the middle. 4 here represents the 50th percentile of our data set. The first half of the data set before 4 is Q1 or first quartile. The second half of the data set after 4 is Q3 or the third quartile. In the first quartile of our data set, we have the numbers 2, 3, 3, starting with 2 as the minimum. In the third quartile of our data set, we have the numbers 4, 8, 20 with 20 as the maximum. Next, we proceed to find the median of the Q1 data set. In Q1 data set, 3 is the median. Similarly, we find the median of the Q3 data set, which is 8. Now we have the Q1 median and Q3 median. All we need to do is subtract Q1 median from the Q3 median. So we subtract 3 from 8 and we get the IQR of 5. So 5 is the IQR of our data set. Since we are dealing with IQR, let's move on to outliers. What are outliers? To put simply, they are extreme numbers or numbers which are distant from the rest in the data set. Outliers can occur due to several reasons. They can indicate deviations, human error, or faulty equipment. In experimental data, they can indicate something unusual, which might require further investigation. They can indicate a non-normal distribution, which we will explain in later sessions. Outliers are observations within the dataset, so they must be accounted for. It is usually not wise to ignore outliers. Now let's see how to identify outliers. Outliers can be determined mainly in two ways. One approach is to use model-based methods to identify if the data is from a normal distribution. This is done by noting observations which are unusual or unlikely based on mean, standard deviation, and skewness. We will explore what these terms indicate in the coming sessions. Another way to identify outliers is to use the IQR, more specifically the 1.5 IQR rule. We saw earlier IQR is the difference between the third and the first quartiles. The IQR is actually a good, robust measure of sample dispersion and is used to flag observations. With the 1.5 IQR rule, we can find out which observations are outside the lower and upper limits. To define formally, an outlier is an observation that falls below the first quartile of the 1.5 IQR and any observation that is above the third quartile of the 1.5 IQR. So let's see how we can find outliers in our dataset. The formula to find outliers is square bracket open Q1 minus 1.5 IQR, comma Q3 plus 1.5 IQR, square brackets closed, which gives the lower limit, comma upper limit. For the data set 2, 8, 3, 3, 24, 4, we have already calculated Q1 median, which is 3, and Q3 median, which is 8. We have also calculated the IQR, which is 8 minus 3, which equals 5. So now we input the values into the formula to get the lower and upper limits as shown. We calculate the lower limit as 3 minus parenthesis open 1.5 into 5 parenthesis closed, which gives us minus 4.5. Similarly, we calculate the upper limit as 8 plus parenthesis open 1.5 into 5 parenthesis closed, which gives us 15.5. So anything below minus 4.5 and anything above 15.5 will be an outlier in this dataset. In our dataset, 20 is the outlier. Hope you liked the session today. It's been a long session, but I hope you liked it. We have mentioned many terms in our slides in this session like distribution, variance, standard deviation, t-test, z-test, and so on. In our next session, we will cover some of these. Stay tuned and stay safe. Thank you for your time. Bye.